Okay, as we continue on with our derivatives unit, we are going to look at something called the power rule, which basically works when you are trying to find the derivative of a function. What you're going to do is you're going to take whatever your exponent is. So in this case, it's n. I'm going to move it out front. So I'm going to have n, and I still have x, but this time it's going to be my exponent is going to be one less. So I'm going to multiply whatever my exponent is by my base of my function, the base of my exponent, and then I'm going to downgrade my exponent by 1 unit. So there's a couple rules we have to note when we use this rule. First is that all radicals convert to rational exponents. So again, we want everything to be exponents, basically. We have to bring all denominator variables up to the numerator. And then third is that all parentheses resolved and all terms expanded. So let's take a look at some examples so we can see what that means. So if we start with a super kind of like simple example, let's say that we have y equals x to the 7th. So again, I'm thinking, all right, I'm going to take this, I'm going to move it out front. So the derivative, or y prime, of y equals x to the 7th power is, just making that clear, is going to be 7x to the 7 minus 1, which again means 7x to the 6th power. If I looked at a slightly different example, I may say, all right, let's say our function is y equals 1 over x to the 5th power. I have to remove, one of my rules says I can't really do this with the denominator. So if I can move this to my numerator, I want to do that. And I can by creating a negative exponent. So really, this is the same thing as saying x to the negative 5th power. When we have a negative exponent, we bring it to our denominator. So if I follow my rules to find the derivative, I'm going to take this negative 5, move it out front, and then think negative 5 minus 1. That's actually going to be negative 6. So if I were to write this function out, I would say y prime is negative 5 over x to the 6th power, because I want to, eventually I do want to get rid of that negative exponent, and I do that by bringing it down to my denominator. All right, let's do a couple more examples. Y equals 3 over x to the 7th power. So I'm going to look at this and I'm going to say, there. I'm going to say, all right, to find y prime, I'm going to make this into 3x to the negative 7th power. So when I bring this number out front, I have to multiply. So 3 times negative 7 to the negative 7 minus 1, negative 21x to the negative 8. So I'm going to say that my final answer is negative 21x over x to the 8th power. It's a good reminder that when we have square root signs, we can create functions with those as well. So f of x equals, let's say, to the 5th root of x. we could rewrite this function as x to the 1/5 power. So when I follow the power rule and I bring this out front, my derivative of x is going to be 1/5 x, and it's going to be 1/5 minus 1. So 1/5 x to the negative 4/5. We're going to go ahead and bring this x to the negative 4/5 down below. So we're going to get an answer of the derivative of f of x is x, or excuse me, 1/5 x to the 4/5 power. Couple more examples here. Let's say that we have the function y equals 6 over parentheses 5x to the third. I'm going to distribute this power of 3 to both terms. So I'm going to kind of rewrite this as y equals 6 over 5 to the third x to the third, which again can simplify to 125 x to the third. Now I'm going to move that x to the third to the top. So I'm going to get 6x to the negative third over 125. And now I can go ahead and find the derivative. So if I take this function and move it out front, I'm going to get 6 times negative 3 is negative 18x. Negative 3 minus 1 is negative 4 over 125. And then my last step is to get rid of my negative exponent. So I'm going to say that I have negative 18 over 125 x to the fourth. Let's find the derivative of a function. So let's say that we have g of t equals t squared minus 4 over t to the third. What I'm going to do is I'm going to, again, move my t to the third that's in my denominator to the top. So I'm going to rewrite this as t squared minus 4t to the negative 3. Now I need to take the derivative of this function and the derivative of this. I'm going to get, so the derivative of g of t is 2t to the first. I don't need to write the first power. Minus 4 times negative 3. 4 times negative 3t. Negative 3 minus 1 is negative 4. So 2t plus 12t to the negative 4, which we know that we have to remove that negative exponent and get 2t plus 12 over t to the fourth. So the derivative of g of t equals this. Let's do 2 more examples of these. F of x equals 2x to the fourth minus x over x to the third. So again, just for starters, I'm going to move that variable from my denominator to the numerator, and I'm going to do that by making a negative exponent. Now I can go ahead and simplify. So again, 2x to the fourth times x to the third, that's really like saying negative 4 plus negative 3 minus, again, this is x to the first minus x to the third. So I'm going to get 2x to the positive 1 minus x to the negative 2, which we can simplify to 2x over x squared. we actually want to keep it in this form so that we can use our power rule. So now I'm going to find the derivative of this function. Bring a 1, that doesn't really matter. So again, if you notice that you have a power of 1, all you're left with is the coefficient. So in this case, my coefficient is 2, and then this is plus, well, let's see here, negative times a negative is a positive, 2, and then again x to the negative 3, so 2 plus 2 over x to the third. That's the derivative. Last example, we're going to take those square root signs again, those radical signs, and instead of using my radical symbol, I'm going to change to exponents. So I'm going to write this as x to the 1/2 minus 6x to the 1/3. Now I can find the derivative, which is 1/2 x to the negative 1/2 minus 6 times 1/3 x to the, let's see here, 1/3 minus 1 is negative 2/3. So I'm going to start simplifying. This is going to give me 1 over 2x to the 1/2. And then minus 6 times 1/3 is 2. And then over x to the 2/3. So let me just rewrite that so it's a little bit easier to see. The function of x is 1 over 2x to the 1/2 minus 2 over x to the 2/3. Power rule.